Yeah, by the way, this is the first time I'm on this side of the table, so bear with me through any hiccups. And I mean literally. Uh, yeah, so without further ado, my name is Nirav. I work at a company called Xactly, and this company has been there for over 13 years. So we do sales performance, incentive management, territory management, etc. We work with company like Salesforce, it's our biggest partner and one of the biggest customer, and we have over 1,600 customers. We've been a SaaS company, get to go from last 13 years. So we have tons of data from customers over the years. And just last 5 years, we started to look into the big data initiative and how we can get the values of our data, right, for our customers. Yeah, the stairs that it's been chose a great place to work for 15 times. Yeah, it's a great company. We are down here in San Jose, and your office is in Denver, Romania, India. I don't see my notes here. Okay. Anyway, so yeah, so company, as I mentioned, company does the sales performance, sales compensation management. So it's very important for sales organizations, especially sales admin and sales executives, to look into their data sets and find out how their sales reps doing compared to their competitors, compared to other industries, and in general, quarter by quarter. So that basically clicked that, okay, we have this data and we should start building some software. So we did started benchmarking software building. We had very similar idea to like Apache Kylin had in 2013. We started going from like NoSQL, just from NoSQL, we started using Apache Spark from 0.8 version. So we've been using Apache Spark from 0.8 version for real-time analytics. And it's been in production over 4 years, all of the applications. But like since last 4 years, we have more and more applications demanding similar kind of solution on top of the big data. Like we have full text search, we have analytics reporting, besides all the benchmarking that basically want to run on the big data sets we have. So that's where we saw a limit just working with the vanilla Spark, because there's, I don't know how many people work with the Spark over here. Right, so you might know how difficult it is to tune the Spark queries, memory management, right? If you have your work with like 0.8, well, right now it's pretty better, 2.3, but 0.8, 1.0, it was like no clue, right? Like you spend a lot of hours on production systems debugging issues. So yeah, so that was one of the pain point, and so we always keep looking for what's new, what's the latest in the data analytics that can help us. So yeah, as for the agenda, I will go through like what are our business analytics requirement over the years, last 4 years, 5 years, what are the technical challenges and technical side of requirements we have, because we have hundreds of terabytes of empirical data, but we are still not a huge company. We don't like, on one of the slides he mentioned eBay has 15,000 nodes. You can take 30 out, and that's the ballpark number of nodes we have. So resource optimizations becomes very critical, like where every team wants to use MapReduce, Spark, Hive, Drill. We need to find a way to optimize the resource utilization. So that was one of the pain point too. So that's one of our technical requirements. And then we went through different solutions over last couple years. And I'll go over why we chose Kyligence. What are the things that we really like in Kyligence? Yeah, some of the business requirements is support over 100 terabytes of data, thousands of customers, and then hundreds of concurrent users. These are all users, almost all users are customers. They are they are basically firing queries like 100 queries per second. It's not super huge, but it's still every query is hitting the millions of records. And then our SLA has been seconds or sub-seconds, and then we have to meet that. Scalability has been issues because as we add more customers, we get more data, and also as we add more features, it makes the serving the query difficult. Flexibility and short turnaround time. That's one of the biggest pain point with your any in-house solution. Like if you use your so in-house solution, we basically does the same thing, right? We all have a data pipeline, and then we pre-aggregate data, and then we have a front-end solution, so REST API, where basically you can query the data in a real time. So real-time data query is faster because you have pre-aggregated the data, right? You have done some kind of cubing. So basically, we didn't call it Cube, but we use a similar technology like HBase. We use MapR distributions. It's called MapRDB. We use similar kind of techniques, like we create bitmap indexes on the data. We create subsets of on dimensions. But this all requires to go through entire development lifecycle. It has to, like, every time when there's in features, when there's a request for new dimensions to add, let's say you want to add new filter criteria in like one of the dashboard, or we want to group by, like, let's say we are grouping by time, but now somebody wants to group by industry types or something, right? So every time such change comes in, we have to change the data pipeline. Or let's add this attribute. Let's get this attribute from data source. Let's add this. Put this aggregators, change the aggregators. We change MapReduce code. We change Spark code, and then in the front end side, we also have to support that in the query, right? So it's a whole cycle that takes long turnaround, basically 2 to 3 months anywhere. So that was a pain point, and cost effectiveness, mainly the resource optimization I mentioned. If you have like 10, 15, 20 nodes cluster, you can't run everything together. Low maintenance cost, easy migration, fast adoption. So any new technology that we want to adopt, we want to make sure it's not geared towards just only our current needs and current applications. But if we see like 3 or 4 different applications using the big data, we want to make sure that solution basically would be able to support all the different applications, different verticals of the business. Some more technical requirements were, some of our product and analyst user, they use BI tools like Tableau, so, and Oracle BI, traditional BI tools. So we want a tool that can that have connectivity to the BI tools. Rich user interface and SQL supports, right? That was also important because we have currently a traditional BI system that is just for reporting. I'm sure like a lot of CRM companies have that, like Oracle BI or Microsoft BI, right? So our goal is to kind of actually move away from that as well and adapt big data technology, even for reporting. And then for people who've been building and working with those technologies, they are very familiar with SQL. They really like the nice user interface where you can design your star schema, snowflake schema, you can design your cubes. So for them, it's very important that there's a nice UI support and SQL support. So that was one of the highest requirements. Data management, right? So another thing about our business problem or challenge is our data is basically CRM, transactional data sets. So it's not an append-only data set. We do historical changes, and we have to propagate those historical changes into all our big data solutions. So if you process certain data sets, for example, a time T1 a data from yesterday, there's some change happened today on the data of yesterday, we have to go and override the data. Normally, no Hadoop ecosystem component supports overriding the existing data, big data. Any big data system, basically, they work on insert of the data. So that's a unique problem that we had, and that's one of the top priority. Another is incremental data reload. So because of the first problem that we had, our traditional pipeline has been like we would refresh all the data all the time. So our refresh frequency would be less. Like in a traditional pipeline that we have, we would refresh data every few days, the entire data sets. That takes lots of resources, but that removes the challenge that we have to handle with the first one, right? But now we want to refresh our data set even faster, like 30 minutes or 1 hour, ideally. So to do a 1 hour, we cannot refresh the entire data sets. So we have to come up with the incremental data sets. And incremental reloading on transitional data set is a huge challenge. It's not a trivial problem to solve. So that's one of the problems. This one, like, yeah, ability to support huge number of dimensions and certain dimensions with high cardinalities. High cardinals means out of billion rows, there are few 100 million records are very unique. So compressing them is difficult problem. Integration, yeah, seamless integrations, any solution that we choose, it has to have rich API interfaces so we can integrate with existing data pipeline, right? So we don't want somebody to go manually click something to start it or stop it, to look into it. We want basically all the features that any good microservice should have, like deployability, connectivity, introspection, monitoring, all that through APIs. So that's one of the requirements. Yeah, strong job monitoring and alerting support. Yeah, I think we already. Right, so I'll go over the tools that we tested over the years. Spark, I mentioned we've been using for 4 or 5 years. So at some point we started looking at other solutions. Druid, Apache Kylin was actually the first one that clicked. In 2015, I attended Spark Summit where I met Kylin people, and that was like very impressive. I dig the technologies as well as the passion that they had to make this space, solve this problem very efficiently for a lot of people. That really clicked us. So Kylin was on our mind. Then we looked into Apache Druid too. And then we looked at 3 or 4 different proprietary solutions, including Kyligence. And so I'll go over them a little bit, like left to right. So Spark, I already mentioned, it's an amazing tool. We Xactly love it. We've been building real-time solution, analytic solutions, benchmarking. Even we have certain machine learning models that helps customer take very critical decision based on Spark. We absolutely love Spark, no doubt about it. But they have its bad sides as well. It's like as I mentioned, like it's difficult to tune. It's difficult to debug, optimize, and it takes a lot of resources as well. So it's and then also if you want to, and then turnaround time for the features is also very difficult with the Spark. So if you want to build something like Kylin on yourself on top of Spark, that's a tons of effort, and that's kind of resource we don't have. We are a small company. Our data team is even smaller. We just don't have that many resources. But yeah. So we were looking something that would add bells and whistles to on top of what we had, and provide real business value. Business value is definitely able to build data sets faster, pre-aggregation faster, and release the features to customer faster. Yeah, so at some point we looked at Apache Druid. I think it was a couple years back. So my information on Druid might be a little bit outdated. I know because at that point they were under very heavy development and they have good community support as well. But there were a few things that just no for us. One of those things is number of components that we have to deploy in order for build the bitmap indexes, in order to gas the data and in order to serve the queries. And those all like components like broker nodes, historical nodes, storage nodes, um, I think even coordinator nodes, they all seem very redundant to our existing deployment. Like if you have Zookeeper, Yarn, Mapart, things running, then you are basically creating a parallel cluster with Druid. You have to give dedicated resources to that. And so that we felt that that would create more problem for us than it would solve. And other thing is it didn't have UI support at that point. I think the pivot was the company you can get a paid support from them, but that was not concrete at the time. Uh, there's no SQL support as well. They have their own proprietary query DSL. So um, like you basically send a REST API, some JSON response, just like Google Analytics if you have used Google Analytics to run any queries. So it's not a SQL. So you can't express any form of joins, any aggregations, or if you have like complex queries, subqueries, you can't do that. So there were a few limitations definitely with Druid, but again, it could have been a good solution for some other scenarios. It could be a pretty good option to a NoSQL if you're just looking for simple analytics on your raw data stored in Hadoop. It could be good solution. And also if you have resources to manage and deploy so many components on your cluster. So next we looked at Kylin. That we did spend like few months about Kylin. We deployed it, tested it, tried to run it. From get-go, one of the issue, not with Kylin, but since we being Mapr distributions, Mapr has its own proprietary database, MapRDB, which is similar to HBase, but it's not HBase. So and then for Kylin, the requirement is you need HBase. And we didn't want it to maintain another database on our cluster where we already have a vendor-proven database, which is very low cost maintenance, almost no maintenance to maintain MapRDB. But HBase, we had from experience, we know it could be tricky to maintain HBase if you don't have resources. So again, with Kylin, we saw the same. On the hindsight, we thought, okay, it's going to create problem for us, but still we went ahead with a small cluster, try it out. Then, so SQL is pretty good. It supports SQL, has a lot of aggregators like some average, even percentile. So that's great. We use percentile, post percentile, even accurate percentile in our production. It does support star schema modeling, cube building, cube optimization. As we talked about, you can create different aggregate groups and define hierarchy dimensions. Basically, so if you have like 10 dimensions, you can end up with 2 raised to 10 cuboids, right? But with optimization, you can reduce that to 2 raised to 2 or even 2 or 4 dimensions, right? So that's still Kylin had that. We definitely love that. Like, but yeah, as I mentioned, the cons for mainly the Mapr compatibility, HBase dependency, also as being a CRM company, being a very customer-focused company, we do like any big technologies we incorporate. We do like professional support. That's kind of important from business perspective. So that's also kind of negative. Yeah, no doubt. I mean, Kylin team community is very active, as they mentioned. But still, like for a business perspective, people, it matters to have professional support. That was important as well. And I think at that time, the querying the raw data, the pushdown query was not available. I might be wrong, but to query any data set to Kylin, you had to build a cube. It's not that you can directly send the data to the your raw query to raw data sets. It's probably changed now. In Kylin is also under heavy development, so some of the details might be outdated. But yeah, HBase is still there, and even if we have to choose Kylin today, it would be a difficult choice just because of HBase. But then there are other builds, there are other good features that Kyligence brought us that I'll talk about later. And actually, yeah, the incremental data support, data reload for transactional data set, that was also something that we couldn't find answer with Kylin. The Kylin does support incremental reload, but based on time series data. So if you have time series data, insert only data, good and well, but that's not the case with us. So we couldn't rely on Kylin at that time. We started engaging Kylin too much, so that at some point they said, okay, maybe you should talk to our partners, Kyligence, about that. And that's actually how we started talking to Kyligence. Yeah, so this is like the comparison of Kyligence with a few other solutions. We tried a little bit more, like 2-3 solution others, but like 2 would kind of give you some idea, and you're not giving any names, but it would kind of give you some idea of like all the solutions that's available in the market, like what they use. With Kylin, what we like mostly is it's not just OLAP on big data. It's not MOLAP, but it's just like traditional OLAP as well. So you can query your raw data and you can run join query as it is like a relational database. And you can also build a cube on top of it. So you have like both advantage. Because building the cube takes time sometimes. Meanwhile, the cube is building, your query would still run on the raw data sets. So that's what we're looking for. And then we found that with Kylin, other solution, a couple of other solutions, they provide OLAP on big data with some limited control over cube building. And then some other solutions, they provide adaptive OLAP, which is basically you still keep running your queries as it is. You don't build any cubes, but the system over the time learns about your queries. They learn the slow running queries, they learn about the most frequently running queries, and they build the cube themselves. So you don't have control, but they would learn it over the time. But that was also no-no for us because of the initial performance that would be low with those systems. And also we wouldn't have, there wouldn't be any transparency at what that system is doing. So that is kind of no-no for us as well, that we do want to have some control on what cubes that we are building, because at the end of the day, when the cube is built, it's gonna explode, right? So it's gonna basically take data space. It's gonna take resources, and when you don't have control over that, especially in a scenario where you have limited resources, then it's a little bit worrisome. Another big point about requirement was the schema modeling and the management and the cube management as well. So you can do it all, everything through APIs, and with most solutions with APIs and some other tools, but having a good rich UI support makes a difference. It makes things a lot faster. When you have, let's say, when you have people who have not worked on cube technologies, try to learn about the technology. So when you have when you have to make the quick changes to your cubes or your cube changes to the data source that you have loaded, it's very important that you have a good UI support, right? So that's what we got from Kyligence, or is there in Kylin too. But Kyligence took it, I personally think is Kyligence took it like few steps forward. One of the best things that I like about the schema management is like once you import your data source, Kyligence have SQL analyzer or SQL-based schema modeling. So you can literally take the SQL or set of SQLs from your traditional system, put SQL in there, and it will generate the star schema and the snowflake schema model for you. So you don't have to drag and drop anything. You can do a drag and drop and create the models, create the joins, everything. But if you just enter like hundreds of SQL, that's what we did in our POC. We took the hundreds of SQLs from our Oracle system, the slow running queries, frequently running queries. We collected those, just inserted them. It created like 4 different models for us. And then the same thing you can use for the cube building as well. You can use the SQL to create the cubes. So you don't have to even learn about aggregator groups or joint dimension or hierarchy dimensions to a number of cuboids. You just push the sequels. It will optimally create all the aggregator groups. It will be like 50 aggregator groups for one case. So if I had to do it myself, I'd be like pulling my hair, whatever left of it. So it's a pretty good tool for us. Like you just import the sequels and it will build the cubes for you. I mean, it will build the cube definition for you. And incremental data reload, I think that's another big plus with Kyligence. Oh yeah, by the way, with the schema management, none of the other solutions we saw this level, this much detail of UI support that you can use easily and build because most of the tools in this space, the proprietary one, they are really new. They are all ramping up. So it's, I mean, it was expected, but the Kyligence, I think, had the best UI possible to manage. So it makes sense. It really is a good business value when you think about maintenance and initial development effort. Pre-aggregation, right? So basically building the cubes. You can use MapReduce and Spark. Other tools, they use proprietary technologies, or they use something that we didn't know what they were using it. But it was also hard to define in some of the tools because their original main philosophy is not to build cubes or not to do any pre-aggregation, but instead they had different philosophy that they would either build it by themselves, or they would just do the in-memory computation every time on the fly. So as Daniel mentioned, if you can do in memory and on the fly computation for the smaller data sets, it's fine. But as soon as your data start to grow, it would be very difficult to maintain that. In fact, one of the solutions in a POC, it was going out of memory a lot of time, and that's why we dropped that POC at some point. Yeah, so incremental data reload is on the big piece for us. As I mentioned, for the transactional data set, where you have to make the historical changes, your partitions is not really based on time. It could be very arbitrary key. It could be like business ID, tenant ID, transaction IDs. So to do a partitioning to do an incremental reload on based on those kind of key change the data, it's not something that is supported by any of the big data technologies off the shelf. So Kyligence, they came forward to that. They didn't had that solution about a year ago. But when we talk about this requirement upfront, they started looking into that solution. And today we have that. It also have a rich API. It's also integrated in our data pipeline. So we are literally rebuilding our old data pipeline, which used to refresh the entire data set all the time. We are completely rewriting the new data pipeline with some Spark jobs in front, but then eventually the Kyligence would come in. So Spark jobs would do some incremental data processing. It will update the file system. Now they use that Parquet or some proprietary file system. So we don't have to rely on HBase, but that file system is basically backed by Hive. So we just update the partition and then tell Kyligence through the API, hey, this partition got updated, pick that up and update only that part of the cube. And that's been done. And that's the performance is pretty great. We already have a pretty good result from our response from stakeholders. So that's a huge win for us to move our entire data pipeline to support the incremental data reload on transactional data sets. With other solution, it was not supported at all. They simply don't support anything other than timestamp for incremental data reload. And some solution, they had it on roadmap, but they didn't commit any timeline to us. So that was also difficult for us to go ahead. Query execution, performance, almost all solution we had, I think concurrency and latency number, almost all solutions were comparable. So again, like Kyligence did do a pretty good job in that, especially with the push down queries, because that's something we wouldn't have expected from the Cube engine, OLAP engine. But the push down, you can basically, we chose Spark as a push down engine. And so every time when a cube is in process of building, or we haven't built a cube yet, our push down will still go through a Spark SQL, and it will use the Spark executors, the same Spark executors that Kylin would use once the cube is built, right? So we could still get the Spark executor to run our queries, and it's still within few seconds, and it does mix SLA. So that's good. And once the cube is building, obviously those queries are much faster. Query optimization is, as I mentioned, super easy job. It also maintains with fit monitoring support. It monitors response time for every query that you're making on a system. So it has a list of slow queries. So you can go into that system, pick up the slow queries. Excuse me, part about hiccups. So you can pick up the slow queries or any new queries that you want to support. For example, one of the use cases I mentioned about new features, right? Supporting new dimensions or new filter criteria or new group by criteria. You just modify some queries that includes those criteria and put that query in your cube definition, and it will automatically modify the cube definition. It will add those dimensions. It will create more cuboids if it needs to as a definitions. And then once you build the cube, that query is basically going to be supported by cube instead of going to the push down. So that's a simple process. With other solution, we could do that, but in solution B, as you say, we don't have control. It just when their system identify that it's a slow running query, they will try to optimize, and then one other system where basically it was possible, but the thing is you have to put effort like in how to optimize it. Like you have to like create set of queries and kind of see, okay, this cube would fit this set of queries, this cube would fit this set of queries. You have to kind of do certain analysis on your queries and your query patterns, and how and also you have to know about the statistics of the data, that what kind of columns you are including in those queries, what is the cardinalities of the columns in that queries, what is the how much number of records you're going to be returning from that queries. So you have to do a lot of analysis and statistical analysis to actually build something like cubes in those other systems. So that we saw as so in Kyligence, we definitely saw it as a maintenance advantage, ongoing maintenance advantage. Okay, we can do this turnaround pretty fast with Kyligence compared to these other solutions where we have to put a lot of mind into it. Not that we don't like to put a mind into it, but that's an option with the Kyligence as well. If you want to build your cube by yourself instead of query pattern, you're free to do that. You can define tons of aggregator groups if you think this is the best choice, and you can still do that with the Kyligence. And API support, as I mentioned, we wanted a completely autonomous integration with our existing data pipeline. It has to completely support, basically it has to be reliable, robust. If any jobs or cuboid job fails, we need to get an alert. We need to have certain flexibility that we can set, okay, if this segment fails, do a retry. If this segment on this cube fails, don't do a retry. And those kind of things basically make the system resilient by itself, with minimum intervention from a human. And then they had a good API support, but I think over last few months and last several major release, they have even richer API integration now, based on some of the response from us. So that's also lacking in other solutions. So yeah, so that's so yeah. So if I have to just pick two elements why we choose Kyligence over Kylin or some other solution, was I would say one is incremental data reload on transactional data sets. and schema management, modeling, and cube building, cube optimization. Those are I from my experience working on a Spark last almost 4 or 5 years, I think it saves a lot of time, and then you learn good new technologies as well. Yeah, I think that sums it up.
It's conduct from Xactly. So, just to add on Kyligence, one of the advantages someone asked about why Kyligence, why not Kyligence? Of course, we are not as big as eBay, and we have limited set of resources in terms of human as well as the cluster. So we have to determine what is the best, right? And just by SPM vendor or SaaS enterprise company, our customer demands fast time to market, right? Anything they want. So balancing all the factors together, came up with Kyligence is a solution. One of the advantage again of the Kyligence and one of the satisfaction which myself and the CTO has is it's built on an open source, right? We don't want Kyligence to go out of business. Of course, we want them to thrive. But at the same time, it's built on an open source, right? So that gives us some level of satisfaction on it, right? And we have engineers like Nina who can, in case things go sideways, we don't want that again. We want them to succeed, but again, on the business side, we have to make sure that we consider all of the factors, right? And all of other solutions we decide, we looked at it, of course, they have a great solution. Many big companies may use them, right? But it's not something that we can use and we can avoid in our tech stack. And over the time of period, the support Kyligence gave us during their POCs and everything we did,
right,
was great. I mean, they have been followed through all of the promises, including incremental, as you can imagine. We, as a customer like Salesforce or LinkedIn, where all those companies process their compensation, the payments to our system, right? And they make changes to those salespeople on the last year. And we had to accommodate that, right? It actually filters down all the way. So it's not an up-and-related, just like Niro mentioned. So we have to make sure that we don't take days to update our analytical system. It has to be met with minutes, maybe hours,
right?
And all of these things you see, this is a customer-facing app. So this is a slice and dice, which will be used by customers, not an internal. Hopefully that gives a good understanding what and where we are in terms of it. Someone also asked about the AWS. We are also in process of testing AWS with the bring your own license, not the hosted one. We have products which are hosted on AWS, and we're gonna again use. And again, we're not using EMR. Some not EMR. We have a NAPR hosted on AWS, and we're gonna integrate that eventually with Kyligence as well.
Okay, I think, yeah, that's about it. If any questions, you can take it. I know it's pretty late. People want to go home and start Netflix.
Do you face any challenges with incremental processing in cases where you have to change the data?
Yeah, so with Kyligence, you mean?
Yeah.
Right, so one of the things is they rely on Hive schema right now. It's not a huge challenge, and they are working on it. But like, what we have to do is like every time when we have new partitions updates, right? So from upstreams, like there are a series of components, right? So one component we have like publisher subscriber kind of models. One publisher say, okay, I'm done with this partitions. It publish it. Next consumer picks it up. I'm done with this partitions. Publish it. Right. So eventually Kyligence comes in. Like it comes in some certain time. It comes in early. Comes in late. But for Kyligence to know, we have to update the Hive schema, and then basically update the partition on Hive, which is not a bad thing. I mean, it's not. It's just basically update Hive partitions to latest partition. Just tell Kyligence, hey, this partition updated, and you can pick it up. Yeah, but if we can just say that, okay, this data set is changed without Hive being in the middle, that's possible too, and I think they are already looking into it. Yeah. we have a beta solution already, but yeah, that would be nice. But yeah, as for the functionalities, I mean, I think we are almost there. We have already integrated in our development, and yeah, we are excited to release this incremental pipeline. Yeah.
Yeah, one of the other things is some of the other solutions, they need people to actually teach you how solutions work, how you build cubes, how you build certain sets of things, right? Here, Peter was the only guy, of course, Kyligence, Luke and everyone, and then everyone helped, but it's not like they are sitting there for like a month to build your own system, right? It's quite intuitive. It's extremely intuitive.
Right. Yeah, as I mentioned, like we displayed, I mean, demoed Kyligence multiple times to our internal teams, and like when we displayed, I mean, demoed it to our OBI team,
right,
which used the traditional BI. We demoed this versus other proprietary solution as well. They definitely felt a little bit clueless with the solutions because it's not intuitive. At get-go, it didn't feel intuitive to me as well, as intuitive as Kyligence, and they all like Kyligence. They like Kylin as well, but I know like why Kylin is not our best choice for us. But yeah, they love that features of schema modeling, cube building, and optimizing. So you have some transparency into what's going on with your data, and then with other solution, none of us could see that. So that was, I think, very valuable.
Yeah, and it's kind of very important because we're moving from traditional BI into big data markets, right? And for them, the team who actually is managing those cubes, which is on traditional BI system, to have them familiarity with this tool, kind of important, right? So Kyligence was quite
right.
And one of the things we find it really happy as far as my part was, every time Nero makes ask some feature set or anything, they're extremely fast, right? Say, okay, this is our beta build. Try it out, see if it works.
Right. I mean, like over the several months, I would say almost 6 months, we've been constantly engaged with multiple vendors and their support teams. We spend a lot of time to going back and forth on the requirements, and Kyligence was the most fastest in terms of response and in terms of releasing the hot fixes and new features as well. Yeah, that's a good plus point for us.
Great.
All right.
Great presentation. And thank you for staying late.
Yeah, thank you everyone for coming.
You guys must be very passionate about the technology stuff.